1-4 in college algebra, writing the equations and lines. Here we go. Write the equation of the line in slope-intercept form. Man, you got to love the easy ones when they give you the slope and they give you the y-intercept, right? There's nothing easier than that. So it's y equals mx plus b, where m is the slope and b is the y-intercept. How do you feel about that? 4 goes in for m and 1/2 goes in for b. You can't get an easier problem than that. Done. 2, write an equation that goes through the point meow and has a slope of blah. All right. They don't give me the 2 ingredients. Our final answer today needs to be in slope-intercept form. But I got me a slope, boom, but I don't have a y-intercept. But they gave me a point. That is where we will use point-slope form, which again you have to have memorized. You've used it many, many times. I'll just kind of refresh your memory. The point that they give you is your x1, y1. The slope is your m. And you totally just have your x and your y just as part of the actual equation. So we're going to roll with it. Y minus y1. Who is y1? It is the y value of the point they gave you, which is -6. Right? You okay with that? So if I do minus a minus 6, I think we have the memory that that's got to turn into a plus. Right? Minus a minus becomes plus. Slope, -3/4 times the quantity of x minus x1. x1 is 4, so just 4. So is everyone cool with why this turned into a plus? Because it was minus a minus. You all down with that? This is not going to be accepted when my math lab says, dude, put it in slope-intercept form. This is point-slope form. So we need to distribute Mr. 3/4. So y plus 6 comes down. -3/4 x is pretty basic, right? -3/4 times x. And here, yes, you can use a calculator. These are usually so stinking easy you don't need a calculator. I do signs first. What's a negative times a negative? Positive. And then see this right here. Does this number, the denominator, go into this number evenly? How many times does 4 go into 4? Once. Take it times your numerator, you get a 3. You've already figured out your sign, right? It had to come out positive. So 4 went into 4 once, times the numerator is 3. Then to finish this off, I need to subtract 6. I've got to get y all by itself to put it in slope-intercept form. So I'm sure they'll ask, once you do all that, what's the slope? Well, they told it to you. What's the y-intercept? -3. When you graph that, it's going to make a line. Cool. Does the line fall or rise as you look from left to right? It falls, because it's got a negative slope. It's going down from left to right. If you're okay with a point and a slope, we'd have very few examples today, right? When they give you a point, they give you a slope, you use point-slope form. Let's keep rolling. Write the equation of a vertical line that goes through this point. I love writing the equation of vertical lines and horizontal lines because they're easy. Vertical lines only have x with it. X is going to equal. It's got to go through this point. What do you think if we go through that point? Should x equal 9 or should x equal -10? It's the x value, right? X equals 9. Boom. What kind of slope does it have? 0 or undefined? Undefined slope. Right? That was from last class period. Vertical lines have an undefined slope. You okay with that? Done. You can't put it in slope-intercept form because there is no slope. It's an undefined slope. So vertical lines will always be x equals this. Bless you. Write the equation of a line that passes through these 2 points. Hey, you can either do it with a lot of work or sometimes there's a shortcut. Let's see if we can take a shortcut. I check to see if this line is horizontal or vertical first. The way you could tell if it is vertical is both the x values have to be the same. Are both the x values the same? They are not. The way you could tell if it's horizontal is that both of the y values are the same. Are both of these y values the same? Boom. So we're done. It is a horizontal line that goes through these points. It's just going to be y equals 2. Because that's literally what y equals. The slope is 0. Right? If you went and found the slope, you would get nothing. You put it in the slope-intercept form, and you would get this. So that was a horizontal line. Bonus time. That's a 1. Sorry for the bad handwriting. 1, 5, and 1, 11. Can you tell by looking if that is horizontal, vertical, or oblique? Is somebody the same? Who's the same? The x's. What is the equation of the line that's contained by those 2 points? X equals 1. Right? Yes, you definitely need the x equals. How about these two? 2, 3, and 5, 11. Can you tell if that's horizontal? Is it horizontal? Nope, the y's aren't the same. Is it vertical? Nope, the x's aren't the same. So you'd have to go through some work to write the equation of that line, which I assume we have to do next. Yes. Can you tell here that this is not vertical? Boom, boom. Those guys are not the same, the x's. And the y's are also not the same. So here's what we need. We need 2 ingredients. We need to know the slope, and we need to know the y-intercept. First, let's find the slope. Please put a little m equals. Show me what you're doing. y2 minus y1 over x2 minus x1. If I move too fast, slow me down, please. Slow me down. Find the slope. That is 6 over 6. If you have to ask this question, that's fine, but you haven't been paying attention your whole math life. Should we reduce that? What do you think? Always reduce, right? So that is 1. Are you down with that? Then I got the slope. Now I need the y-intercept. How do I find the y-intercept? With point-slope form. Because we have a point, we actually have 2 of them, and we have the slope. So pick a point, any point, it doesn't matter. I don't care. I usually circle the point that I'm using, so I'm going to use this point and use point-slope form. Why don't you please pause the video and see if you can substitute that in correct. The point that they want me to put in is -2, 1. So here's my y1 right here. Here's my x1 right here. And I had to do minus a minus. You honestly don't have to put the 1 in front of here since the slope is 1. But if it was any other number besides 1, you'd have to put it out there, right? But if you're like, dude, I don't need that because you just distribute it, you get the same thing. So you got y minus 1 equals x plus 2, and add over. And this is the answer that you type into my math lab. Y equals x plus 3. Yes, you could put a 1 in front of it. It would probably accept that also if you wanted to in that situation. Cool? Usually the biggest mistake is maybe you don't use the letters that they told you to use. So, all right. Why don't you and your neighbor, now if you're watching this on the video, please don't go over to your neighbor's house and try to do this equation. I'm just talking to the kids in class. You and your neighbor get this done. Should be done by now. What is the equation of the line that contained by these 2 points? X equals 9. What kind of line is that? Horizontal, vertical, or oblique? Vertical. What's the slope? Undefined. Hey, if they give you the freebies, take the freebies, man. You know? Cool. Let's keep rolling. Here's where we start getting into those. It's like, hey, could you help me with this one? Right? It's like, how do I do this? They give you an x-intercept of -5 and a y-intercept of 4. Remember, we want to write our final answer in slope-intercept form, which we need a slope, which they don't give us. We don't have the slope. But we do have the y-intercept. Are you down with the fact that we got the y-intercept? So I've got to find the slope. People are like, whoa, bro, how do you do that? You take this English and you turn it into math. If they give you an x, let's start with the y-intercept real quick. Like if I sketch this out, and if the y-intercept was 4, right? It's like right here. Could you tell me what that is as an ordered pair? Like what is that point as an ordered pair? Isn't it 0, 4? What I think you should do is write that right here. This is the point 0, 4. And then very similarly, if there's an x-intercept of -5, could you write that as an ordered pair? What does an x-intercept of -5 actually turn out to be? -5, 0. See, they didn't give you 2 points. You had to write them yourself. Right? You had to write them yourself. Now, can we find the slope between those 2 points? So, m equals y2 minus y1 over x2 minus x1. Try it yourself. Don't copy me. You know, if I could take your final exam for you, I would. And we'd get 100 on it. But unfortunately, you have to do it. Right? And I got 4/5 for a slope. Is that okay? Remember the minus becomes a plus? Hey, if you go through and do point-slope form, it'll work. But we got the slope. Don't we already have the y-intercept? Right? So we don't have to do all that work. Just put it in slope-intercept form. It's back to like problem 1. We got ourselves a slope. And then watch this. I'm going to make a mistake. This is the most honest mistake you could make. You type that in, and my math lab says, wrong. What's wrong with that? I forgot the x, right? The other mistake that might happen to you is you accidentally get x down in the denominator. The way you type it in, you know, it's like you didn't get out of the denominator, and you put an x down there on accident. Make sure you get out of the fraction. I'll help you with that later, and put the x off to the side. Okay with that? So, all right. Then we got our two P words, parallel lines and perpendicular lines. Tell me what you know about parallel line slopes. Parallel lines have the same slope. So, P word, yeah. All right, I need to know the slope of this line. You know, back in the day, a bunch of algebra students thought the slope is always the number in front of x. And that only works if y is all by itself. Is y all by itself in this orange equation right here? So what helps a lot of you is to just get y by itself. There are other shortcuts, and if you know those shortcuts, use them. I'm not going to mark you wrong. But you see, don't I have to like totally subtract the 3x over? Now that I got y all by itself, what is the slope of, I just call it the orange line. It's got an orange box on it. What is the slope of the orange line? -3. We need to use this point, and since they say parallel, use this slope. All right? So we'll use point slope form to get that done. So I'm going to do y minus y1. I'll let you fill that in. y1 is 6. Slope we want to use is -3 times the quantity of x minus x1. Check it with mine. Did you have the right work? Then distribute and put it in slope-intercept form. Old school stuff. To be quite honest with you, this is the 4th year in a row you've done stuff like this. It's all right if you're rusty. It's all right if you have questions. But again, I'm not showing you anything you should have not seen before. That should be -6. Nice? Roll it. Nice. Perpendicular. When you're talking about lines and having perpendicular, and they're perpendicular, tell me what their slopes. 2 words. Starts with an O. Opposite. Starts with an R. Opposite. Reciprocals. Means change the sign and flip it over. Right? Find the slope of this line right here. This does not have y all by itself. If you know a shortcut to find the slope, use it. But what is the slope of the orange line? Find that real quick. So I have put this in slope-intercept form, and I got a slope of -3/2. Don't forget, don't get ahead of yourself. Do you want the same slope, or do you want the opposite reciprocal? You need the opposite reciprocal, right? So who is the opposite reciprocal of -3/2? Now, I always write it down like this. The upside-down capital T, if you remember from geometry, means perpendicular. Little subscript at M means slope. I honestly don't care if you write that down or not. I'm just used to doing it. But if you just know that you're supposed to use a slope of 2/3, I'm good with it. Cool? But I wrote down perpendicular slope equals 2/3, just for my benefit. All right. Now you got the slope you're supposed to use. You got a point you're supposed to go through. Use point slope form to write that equation. Pause the video. Get that done. So I got her subbed in to point slope form. Is everybody cool with where the numbers are and why they're supposed to be there? And then when I wrote it, I saw I'm going to get in trouble due to the fact that this number, denominator, doesn't go into 4 evenly. That's cool. We can figure it out. So I'm going to distribute the 2/3 through, and we can definitely use our calculator to help us with fractions if we want to. So it's 2/3 x. But multiplying fractions actually isn't that bad if you remember. You just take numerator times numerator and denominator times denominator. So 2 times 4 is 8, and 3 times 1 is 3. And you just check to see if 8/3 reduces what it does not. Is everyone cool with 8/3, where that came from? Then I just got to add 5 to it, and due to the fact that this is college algebra, it's time to learn how to do that in a calculator if you have not before. Was it 8/3? Is that what it was? So 8, clear. Put that in parentheses is the safest thing that you can do with fractions, because these graphing calculators don't have fraction bars. And I'm adding 5. Is that what I'm supposed to do? So add 5, hit equals, and then to change that into a fraction, have you seen the math enter before, where you go to the math button, and then you hit enter, and then you hit it one more time, and you get 23/3 back from that. All right, so math, enter, enter. If that's new to you, I will help you. So y equals 2/3 x plus whatever it was supposed to be, 23/3. Here's some other ones that are really weird if you were like all by yourself, and it's like, hey, how do you do this problem? It's not that bad once I show you. I have graphs of these dudes just to show you that, see, this is not a line. It's a parabola. I think we knew that. And slope and rate of change mean the same thing. Well, the rate of change, if you connected those 2 points, is completely different than the rate of change if you connected these 2 points. Don't they have different slopes? That's why when you graph a parabola or you graph a cubic, you can't just rise and run. You know, lines you can do that. These other guys you can't. But whenever they do this is the hard part for the students, to say find the average rate of change. That's a magic phrase that says find the slope. Please find the slope. They want you to find the slope between when x equals -1 and x equals 2. People freak out. Here's my advice. Let's make up some ordered pairs. So first one, let's do 2 ordered pairs. So here's 2 sets of parentheses. In the first one, they want x to be -1. In the second one, they want x to be 2. And you're like, okay, well, what's y? But are you cool with one time x is -1, the other time x is 2? What's y? Right here. It literally tells you what y equals. Y equals x squared. So if I have an x value, in this case -1, would you believe all I need to do is square that? Right? And that would tell me what y is. Help me with the sign. What's -1 squared? Is it 1 or -1? It's 1. Right? So how do you feel that when x was -1, y turned out to be 1 for that situation? How about if x is 2? Substitute that guy in right here. What would y turn out to be if x was 2? 4. Feel good with where those came from. And they want you to find the rate of change between those 2 points. Find the slope. It's that simple. All you needed was those 2 points. Find the slope. Find the slope. Remember, our test is on pencil and paper. I do ask you to show a little bit of work. If it's not exactly like mine and I could figure it out, I'm kind of okay with that these days. But the rate of change between those 2 points is 1. Right? But if you pick 2 other points on the parabola, it might not be 1. There's not a constant rate of change. So let's see if you can do that again down here. This is y equals x cubed. Make yourself up the 2 ordered pairs. You know your x's, right? Just got to figure out what your y's are. If you need to use your calculator to cube something, do it, you know. Right? Figure out what those y values are supposed to be. So -1 cubed is -1, right? And 2 cubed is 8. My pen would work. Come on, pen, work for me. 8. And then finding the slope, 8 plus 1 over 2 plus 1, 9 over tray, which is tray. Hey, we all make mistakes. A lot of times I see a 6 here on accident. It's just called brain fart, you know. It's like it's not 2 times 3, it's 2 times 2 times 2, you know, stuff like that. You feel okay when they say find the average rate of change. You're just finding the slope. You need 2 points. All good? Sweet. Now for the fun stuff. The brand new thing. I know we're a little sleepy and tired. Don't worry. We'll take a little break here in a few minutes to go to lunch. But they want us to find the difference quotient. I'm kind of surprised they have us do that in this class because it's a calculus thing. It's like, what do I need this for? What does this do? Here's my easy answer. Take calculus, and you'll understand what it does, right? But for our purposes, how about we just say, I just need to get the answer, sir. How does that sound? Like, how do I get the answer? So first thing first, this formula you do not have to memorize. It will be provided for you on all tests and quizzes, right? It's one new thing. Using the formula is what I care about. Let's go old school. You know, like here's f of x. Remember that's function notation, right? This is a function. What if I asked you to find f of 2? What does that mean you could do in this situation? Anywhere you see an x, don't you put 2 in that situation, right? So like, don't write this down, but like f of 2 would be 10 times 2, 20 minus 7, and you clean it up to be 13, right? F of whatever they put right here, you put this in for x. Well, it's pretty easy when it's a number. But dude, when it's a letter, it starts messing with people's heads. It's like, wait a minute, how do I deal with that? So let's follow this formula. There's 3 ingredients to it. The orange thing, the blue thing, and the pink thing. You okay with these 3 ingredients? The first thing we need is f of x plus h. Excuse me? Just like I said, if we want to find f of 2, sorry for the pen dragon right there, if we want to find f of 2, don't we put 2 in for x, right? If you want to find f of x plus h, we're going to put x plus h in for x. So let's do that together. It's going to look like this. F of x plus h equals 10, and then you're going to put parentheses wherever x is because we're subbing in a quantity, times x plus h minus 7. That's weird. Where there was an x, we put x plus h in its place. You're kind of down with that, right? It's weird, right? But see what I did. Well, this I can clean up a little bit because there's a number outside parentheses. Can't I distribute that 10 through? So let's just keep going down. Put an equal sign again. 10 times x, 10x. And 10 times h is 10h. And this minus 7 is just still there, but it doesn't get the 10 distributed to it. You cool with that? There's this. I've got the orange thing. Boom! This and this are the same thing. Right? I have found the orange thing. Good? Then, here's what we're going to do. Instead of rewriting this over and over and over again, would you believe I'm not done? I have to subtract away this blue thing and then put it over the pink thing, right? But I don't want to rewrite this. I got the orange thing. It's always going to lead off my scenario. So here's what we're going to do. Follow me first. Watch me before you write. I need to subtract away boom, f of x. I have f of x. They told me what f of x is. What is f of x? It's 10x minus 7. Right? So I need to subtract away 10x minus 7. But watch. If you subtract away 10x minus 7, we talked about this last time. When you subtract away something that's got more than one term, don't you have to distribute that stinking negative through the parentheses in that case? So for a shortcut, instead of writing it like this, doesn't distribute into negative, just change everybody's signs in that case. So here's what we can write for the blue thing. We're going to do, since this is a 10x, it's going to be a minus 10x. And since this is a plus 7, since it's a minus 7, it's going to be a plus 7. You with me on that? We're subtracting away 2 terms, so everybody's sign has to change. So I got the blue thing. It's all supposed to be over h. There is nothing to sub in for h. It's just an h. What does h mean? Like I said again, take calculus. You'll understand. But it's going to go over most of our heads just like that. And you're like, I don't care. So this is what we got. All we have to do is clean that up. And if you look upstairs, do you see you got some like terms? Let me find a cool highlighter that we haven't used. Here's a 10x, and here's a minus 10x. Aren't those like terms? How much do you get when you add those together? Nothing. So I scratch them. Please don't black them out. Just scratch them out. Here's a minus 7. Here's a plus 7. Right? Those are like terms. Then they also add up to be nothing. That is supposed to happen every time. Do you notice that everything went away that didn't have h's with it? The only thing that's left has an h with it. That's going to happen every time. So here's what's left. You got 10h over h. And would you also believe that those h's, since you have one upstairs and downstairs, can cancel each other out? Answer? 10. What does it mean? Take calculus. It's the slope of the tangent line at any point and there's a line, blah, blah, blah. It's like, I do know what it means. It's hard to explain, right? But 10 is our answer. That was weird. We need to do another example, right? So here's what we got to find first. This is the work I basically am begging you to put, almost requiring you to put. We need to find f of x plus h. Why? Because it's the first thing in the formula. So wherever there's an x, we're going to substitute x plus h in its place. Next move, distribute. orange thing. Complete. I have it, right? I have f of x plus h, as weird as it is. Now I need to take away f of x, which means the OG that they gave us right here, we change everybody's signs. So the 2x should be a minus 2x. The plus 3 should be a minus 3. And that takes care of this part. The blue thing, don't forget, it's all over h. The stuff that doesn't have h's with it upstairs is supposed to go away. Here's a positive 2x, there's a negative 2x. They cancel out to be nothing. Here's a plus 3, here's a minus 3. You're left with 2h over h. What's 2h over h turn out to be? 2. I can see that some of you have found a little pattern so far. It works nice for linear guys. Would you believe this is linear? If you graph that, that is a line. If you graph that, that is a line. Even if you see the pattern, I'm going to force you to do the work, right? You have to show the work. But when we get to a quadratic guy, it's a little different in that case. So, you okay with that? Here's what I want to do. You and your neighbor get number 14 done. Please pause the video if you're at home and work on. So I got it all subbed in. I'm going to clean up. 45 minus 15x, come on buddy, minus 15h. That's this. Yeah. Let's take away f of x. So f of x is right here, 45 minus 15x. Since we're taking it away, got to change both signs. Come on, pen, work for me, work for me, work for me. 15x over h. Goodbye, 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 goodbye. H's cancel. Negative 15 is the difference quotient. It's weird, right? It's weird. Look back at those three. Can you predict what the difference quotient is going to be on the next problem? What do you guys think? This one was 10. This one was 2. This one was negative 15. What do you think this one's going to be? 32. But it only works if that's a line, right? All four of those were lines, and it's the slope of the line, right? But when it's different, when it's a quadratic, this is a parabola, it's not going to be so nice, right? So let's get started. If we don't get finished before lunch, we'll go to lunch when we're supposed to go to lunch. Here's what we need first, f of x plus h. Where you see an x, you need to put x plus h in parentheses. And yep, that's got to get squared. And of course, back in the day, our number one error in algebra was a sign error. Now, when we're in more advanced algebra, even in Algebra 2, our number one error, in my opinion, that I saw, is a binomial squared. Right? Binomial is two terms, and when you square it, you know, people think you can just square the x and square the h and call it good. It doesn't work that way. So if you need to, you can always write it like this. It's x plus h times x plus h. And you have to FOIL that out. First outside, inside, last. Right? So help me. What's first terms times each other? What's x times x? It's x squared. Outside terms times each other. X times h is xh. Inside terms times each other. Well, instead of calling it hx, I'm going to call it xh again, you know? So you got another xh. And then finally, last terms times each other, h times h is h squared. If your algebra teacher or geometry teacher or algebra 2 teacher taught you a shortcut for that, we can use it. Because the shortcut for a binomial squared is, after I combine like terms here, you'll see it. It's square the first guy. What's the first term squared going to turn out to be? X squared. Then twice the product of these. That means multiply them together. X times h is xh. But you're going to need two of them because don't they show up twice every single time? There's one xh plus one more xh. So isn't that two xh's? And then you'll square the last guy. If you don't know that shortcut, write them side by side and FOIL them out. And it'll work for you every time. But dude, that's just this. We have taken care of these guys. There is a times 2 on the outside and a plus 4 with it still. You with me on that? There's a times 2 out here, right? And a plus 4. So please distribute Mr. 2 through the parentheses. Algebra. Gotta love it. And then there's that plus 4 at the tail end. Let's finish this real quick. It'll only take a second, then we'll go to lunch. What I have found is this, f of x plus h. That's all we found. The rest is basic. Subtract f of x. So I'll do that in green. Take away f of x. Change everybody's sign, please. How do you feel about those guys right there? And it's all got to be over h. So it's the same story, just a whole lot messier. F of x plus h, complicated. Take away f of x, given to us. Change everybody's signs, over h. Same rules apply. Everything that doesn't have an h with it upstairs is supposed to go away. If you don't get it to go away, you made an algebra mistake, which is pretty normal, right? Show you. You got a 2x squared. That means there better be a minus 2x squared up here somewhere. They go away. So they didn't have h's with them. This 4 and this minus 4 don't have h's with them. They're gone. But would you believe what's left? These 3 nuggets right here all have h's with them. This has an h, this has an h squared with it, and this has an h. So they all have a factor of h in them. They can reduce by 1 level of h. Get rid of an h from here. What's left in this term? Get rid of an h. What's left? 4x. Get rid of an h here. Is it a plus? Is that what it is? So plus. Get rid of an h here. If it's an h squared and you got to knock it down by an h, what does it become? So you just got a 2h, and get rid of this h, right? Because what you did was you canceled, and then you canceled one of those, and there's still one left. So the difference quotient turned out to be 4x plus 2h. This is the answer. You don't solve for x. You don't solve for h. You just get that answer. What does it mean? Take calculus. We'll do another one when we come back. So this one was much wackier because the x was being squared. Let's roll again. Find a little f of x plus h. And I'll show you a cool secret. Oh, I like cool secrets. Where there's an x, we'll put an x plus h in its place. Definitely a lot more work involved with these squared dudes. So here's the cool secret. Every time when you put x plus h in for x and that quantity gets squared, doesn't it like turn out to be the same thing every time? You know, it's like it's not like reinventing the wheel here. So if you can just memorize it, or remember that it's square the first guy, x squared, twice the product of those. So the product of those is xh. You need 2 xh's, and square the last guy. But if you look over, sorry, I kind of erased it a little bit. It's the exact same stinking thing we had right here. Right? It's always going to be x squared plus 2xh plus h squared. And then you have a plus 1. Distribute Mr. 3, and then we do a little cleaning up. Come on, Pam. 3h squared. And then you got your 1 tagging along at the end. Running out of space, but I'm going to go down here. Got to take away f of x. F of x is 3x squared, so minus 3x squared minus 1. Change everybody's sign. Put them over h. That's Spanish for h. Everything that doesn't have an h with it is supposed to go away. 3x squared minus 3x squared. Meow, meow. 1 and a negative 1. Meow, meow. And then right here, every one of these dudes in this triangular formation has an h with it. You're dividing by h, you lose 1 power of h. So this will be a 6 eggs. That'll be a 3h, and that goes away. Very strange. If you need help with the difference quotient, you let me know, and I will help you with it. Work shown? Yes. Remember, my math lab, I can't grade work shown. Test? Shake your head. Hey. Sweet. Please read story. Stop after this part. Cool. They are spending money on the old internet doing some advertising. Right? Here's the tricky stuff that you're going to see throughout this unit. When we read the stories, the first thing you should read for is everything in the same units. Like right here, the amount that they spent on internet advertising was 22.7 billion, right, in 2009, and is expected to grow to a rate of 2.25 billion per year for the next 5 years. First question, are they measuring it in the same amount of units? Right? Billions to billions. Sometimes one of them is billions, the other one is millions, right? So you got to convert. So we got that. They asked us to write an equation for the internet advertising spending after the years after 2009. Remember, it only works for 5 years. So here's what I asked myself. When they gave me that information, you know, we write all our equations in slope-intercept form. It's like, do I have a slope? Do I have like a rate of change that this is happening? What do you think in there? Do we have a slope, rate of change? It's 2.25. Even though in English it says positive right in front of there, you have to go look for other words to see if it's going up or going down. What's the key word in here that says if it's going up or going down? Grow. If it says decline or something, then your slope is negative 2.25 billion. You with me on that? So watch out for that. Then the other thing that sometimes they give us, sometimes they don't, is the y-intercept, which is our initial starting amount. Remember, we're starting in the year 2009. Do we know how much money they spent on internet advertising in 2009? Do they give us that? That's our y-intercept then, right? So we can just rock and roll with it. Y equals, our slope is 2.25. You do not need to put the zeros. You do not need to put the word billion, because I'm sure on my math lab it will have it in billions, you know, like in parentheses or something like that. Need an x next to it, plus 22.7. Rocking and rolling? That's part A. Use the function to estimate the amount that will be spent on internet advertising in 2015. So here's what we got to do. What does x stand for again? We kind of used x. What does it stand for? Recording. Remember, x is basically about a year amount, but we have to go after 2009 because, dude, that's when we started this problem. So if it's 2015, how many years has that been since 2009? So I like to just put off to the side, like work shown, x is 6. Like we know x is 6. It's been 6 years since 2009. So let's substitute that in. I don't care if you show work or not on that, right? If you show this, bing, bang, boom, that tells me exactly what you did. You put 6 in for x. Can you take your calculator and do 2.25 times 6 and add 22.5 to it also in that case? Like that, to me, this is your work shown on it. If you're wanting to write it all down, go for it, bro. But that's simple punch in the calculator. I didn't get my answer sheet out, so I need you to tell me how much that is. 36.2. And then they probably have it for us, but on paper, if it was just on paper, 36.2 isn't enough. 36.2 what? $billion. Right? So how do you feel about that? Good? Nice. Read 19, and then we'll end on a positive note. So, another story. Do they straight up tell me a slope, like a rate of change, or are we going to have to figure that out? Got to figure it out. So I want to write two ordered pairs, x comma y. What does x stand for? They tell us. What does x stand for? The unit sold. So, and y is the profit, or p, whatever. We'll just call it y. So here we go. Unit sold has to be x. So how do you feel about an ordered pair of 346.50? Do you feel good with that as an ordered pair? If I have 300 units sold, I got a profit of this much. The other ordered pair would be this, 375, 9,000. You with me on that? And then, because I'm feeling good today, from here, would you believe that you'd find the slope, get the slope, then pick one of those points and use point-slope form to write the equation, just like we did all worksheet long. You just had to realize to write this. So it's not done. You don't have to finish this. I don't care if we finish it. My question is, do you know what to do from this point? Yes or no? Find the slope, write the equation, put it in. Make sense? Let's do some My Math Lab.